Welcome to this virtual tour of the Department of Industrial Engineering. In this video, both an overview of the field of industrial engineering is provided and a discussion on the value that an industrial engineering degree at Stellenbosch University can offer. By the end of this video, you will not only know a lot more about the many possibilities that accompany an industrial engineering career, but you'll also be excited to form part of a modern, versatile, and forward-thinking department which is at the forefront of the field of industrial engineering. Before asking why study industrial engineering, first ask what is industrial engineering. Industrial engineering is a discipline of engineering dealing with the optimization of complex processes or systems. The field of industrial engineering is concerned with the development, improvement, implementation, and evaluation of integrated systems. These intricately connected systems are made up out of people, money, information, knowledge, equipment, energy, materials, analysis, and synthesis. The result obtainable from such systems and processes can be specified, predicted, and evaluated by consolidating mathematical, physical, and social sciences together with the principles and methods of engineering design. Industrial engineers therefore leave no stone unturned in their pursuit of improvement. Operations management and financial management are business-oriented disciplines that are at the heart of many approaches followed by industrial engineers. However, we follow a scientific approach by emphasizing mathematical rigor and quantitative analysis. In order to better understand the work lives of industrial engineers, consider the following assortment of jobs performed by them. Jobs that are widely applicable to many different industries and offer practical real-life improvements. The first job example is as follows. Industrial engineers are capable of reconfiguring airport check-in services so as to shorten queues and improve passenger satisfaction. Industrial engineers use mathematically derived concepts to analytically solve practical problems that often affect our day-to-day lives. Another industrial engineering job is the design of more efficient car assembly lines, helping to save manufacturing costs. Industrial engineers are obsessed with minimizing wastage, and by minimizing wastage, both cost and time are saved. Another useful job is the streamlining of an operating room so that it is safer, faster, and easier to use. Industrial engineers are equipped with knowledge of industrial ergonomics and behavioral mapping, which can literally save lives. The last example relates to the use of simulation, a powerful tool in any industrial engineer's arsenal. For example, industrial engineers can simulate urban cities so as to understand how cities are likely to evolve, which can support policymakers towards making better decisions. Hopefully by now, you have developed a better intuition into the many different and useful possibilities that will await an industrial engineering career. There are certain qualities that will further contribute towards the unique value proposition you as an industrial engineer can offer. The first differentiating quality is productivity and efficiency. Industrial engineers have an intense desire to optimize or improve systems or processes. They live and breathe by the simple motto of making things better. Analytical thinking. Industrial engineers possess the ability to analyze and use scientific and engineering principles for solving problems. Systems thinking. Industrial engineers adopt an approach to problem solving that considers viewing problems as parts of an overall system. This approach concerns an understanding of a system by examining the linkages and interactions between the elements that compose the entirety of the system. Integrate physical and social sciences. Industrial engineers use an engineering-oriented knowledge of mathematical and physical sciences whilst taking human factors into account. Economic sensitivity. Industrial engineers are known for their understanding of economics and the impact of the decisions on the enterprise's economic well-being. Lastly, management, focus, and ability. Industrial engineers are able to lead resources and projects, and also to advise on management processes of an enterprise. This unique combination of qualities is what separates industrial engineers from any other discipline. It is also this unique combination that future-proofs an industrial engineering degree, especially so at Stellenbosch University. The value of industrial engineering is reflected in the achievements made by the front runners within the field. Let us look at a few of the most influential industrial engineers. Starting with the most famous of them all, Henry Ford. It is well known that he is the founder of the Ford Motor Company. He is universally regarded as the father of modern assembly lines used in mass production. He is also an avid inventor with over 160 patents registered in his name. Another influential industrial engineer is Lillian Gilbreth, the so-called mother of modern management. She pioneered job standardization, incentive wage plans, and job simplification. Certainly a visionary. Moving on to more modern times. Tim Cook is another distinguished industrial engineer. As CEO, he led Apple to the crowning achievement of being the first public company worth over $1 trillion US. In his early days at Apple, he made significant contributions by using his industrial engineering background to develop an expertise in managing supply lines. Some of his most impactful contributions include the reduction of inventory from 1 month to 6 days. The last prominent industrial engineer considered is Meredith Westaffer, a senior industrial engineer at Tesla. She manages the design and layout of the company's prestigious Gigafactory, which will be the world's largest factory based on footprint. It is quite clear that industrial engineers have made significant contributions both historically and currently. This is a trend that will only strengthen as reported in various global market forecasts. Industrial engineering is certainly on the up, and the fourth industrial revolution will only further increase demand. So far, the focus has been placed on industrial engineering in general and within a global context. Let us now turn our attention to industrial engineering in a South African context. According to statistical surveys, industrial engineering is regarded as one of the scarcest skills within South Africa, with abundant job opportunities in various industries. There are various sectors in which industrial engineers are sought after. Manufacturing is certainly a sector in which industrial engineers flourish. Big companies such as Sasol, VW, Tiger Brands, and SA Breweries attract many industrial engineers. Consulting is becoming an increasingly popular destination for industrial engineers. Large consulting firms such as PwC, LTS, Pragma, and Deloitte employ many industrial engineers. Retail also represents another notable sector in which industrial engineers contribute significantly. Companies such as Woolworths, ShopRite, Checkers, and Takealot find great need in industrial engineers. Logistics is closely associated with industrial engineering positions. It should therefore come as no surprise why companies such as Imperial Logistics, Value Logistics, Barloworld, and Transnet all employ industrial engineers. Last but certainly not least, an increasing number of industrial engineers are employed by fintech companies such as Capitec, Standard Bank, Allan Gray, FNB, and Discovery. Certainly a sign of the value associated with industrial engineering. It is apparent that industrial engineers have an illustrious portfolio of companies to choose from within the South African job market. Let us now zoom further in and focus on the Department of Industrial Engineering at Stellenbosch University. This photo displays the entire engineering faculty of Stellenbosch University. Label number 2 indicates the location of the Department of Industrial Engineering, which is housed in a dedicated 5-level, newly refurbished state-of-the-art building. Label number 3 indicates the location of the laboratories of our department. The department has numerous labs, namely the Rapid Product Development Lab, the Reverse Engineering Lab, the Quality Control Lab, and lastly, the Metrology Lab. Let us now turn our attention to the interior of the Industrial Engineering building. As mentioned before, the building is new and therefore offers a modern, inviting, and professional ambience. Large classrooms equipped with multiple projectors facilitate an engaging teaching experience. Adequate power and network points are also provided to further help students. The computer-based classrooms, on the other hand, enable students to be connected, which empowers them to harness the benefits of technology-driven education. The building also comprises secure open-plan areas for postgraduate students, where they are co-located with other postgraduate students in similar focus areas, creating close-knitted, collaborative research groups. On each floor, meeting rooms are available to the students, which can be used to discuss work with lecturers and tutors. Lecturers are situated in close proximity to both the undergraduate and postgraduate students. Students are therefore afforded more intimate and direct access to the intellectual offering of the department, certainly a catalyst for academic excellence. Our attention now turns to the undergraduate curriculum of the bachelor's degree in industrial engineering. Although the first year of undergrad study is by and large generic between the different engineering disciplines, there is a discipline-specific module that serves as a differentiating factor. During the second semester of the first year, an introductory module is presented which covers a few fundamental themes of industrial engineering. The aim of this module is to broaden students' exposure to the impact of implementing industrial engineering specific techniques, as opposed to rules of thumb or other generalized problem-solving heuristics when seeking to improve the operations of a system. More specifically, students are exposed to introductory industrial management, operations research, and quality management theory and techniques, during which the aim is to achieve basic proficiency towards their application. The second year of the program exposes the student to elementary yet important domains within industrial engineering. For example, in the first semester, the module Engineering Economics 214 introduces fundamental notions of accounting underpinned by financing, tax, and growth of a business. The module Production Management 212 introduces the student to operations management, sustainability, process analysis, lean supply chains, and materials requirements planning. In the second semester, the module Industrial Programming 244 focuses on developing students' proficiency in Excel and Visual Basic for application. Manufacturing Processes 244 introduces the student to key concepts and topics ranging from the shaping of plastics to mechanical assembly and additive manufacturing, that is 3D printing. Factory visits and process design projects form an integral part of this module. The remaining modules reside within other engineering domains and expose students to important subject matter and problem-solving methodologies outside the field of industrial engineering. This approach ensures that industrial engineers are kept abreast of fundamental notions in other engineering disciplines. During the third year, far greater emphasis is placed on the central themes of industrial engineering. Manufacturing Systems 344 introduces the students to network automation of manufacturing systems, quality control systems, and material handling equipment. Important notions relating to facility location, facility layout, and demand forecasting are introduced in Production Management 314. Data Analytics 344 focuses on various fundamental aspects of data science, such as the cross-industry standard process for data mining, machine learning, and data-driven decision-making. Operations Research 345 introduces students to the systems approach to problem solving, which is underpinned by mathematical modeling. Engineering Economics 354 addresses themes such as the time value of money, discounted cash flow, inflation, exchange rates, and the macroeconomy. Industrial Management 354 introduces students to supply chain management, logistics management, and enterprise resource planning systems. The fourth and final year is almost entirely focused on purely industrial engineering related modules. Topics ranging from works, station, and tool design to the development and implementation of information systems are addressed. Important notions such as queuing theory as well as the powerful tool of simulation are also introduced. Organizational culture, conflict management, and labor legislation are also included in the final year of study, which are central towards managing organizational behavior. The culmination of the undergraduate program is represented by a so-called industrial project, also known as a SCRIPSI. Students are required to apply their accumulated knowledge towards solving a real-world problem over the course of their final year. A comprehensive report is compiled which details the execution of the project. Students are exposed to a wide range of industry problems to which they can apply their minds. Projects range from the 3D printing of surfboards to the simulation of infectious diseases in informal settlements. The best way to describe the type of work that an industrial engineering graduate from Stellenbosch University will do after leaving our department is by way of a discussion on the diverse research themes of this department. These are the typical areas in which the engineers we produce will work someday. The research themes are operations research and decision support, operations management, systems modeling, engineering management, data science, and manufacturing. Industrial engineers leaving our department are certainly well equipped and can deal with any real-world problem. Let us consider manufacturing in greater detail. This area focuses on development of resource-efficient process chains to ensure sustainable manufacturing as a value creation system of products. The first main sub-area is smart, sustainable, advanced manufacturing, which involves the co-creation of manufactured products through digital, economically sound process chains that minimize negative environmental impacts whilst conserving energy, natural resources, and empowering communities. The next main sub-area is micro-manufacturing, which focuses on machining and microassembly of products in which micromaterial handling systems are utilized. The last of the sub-areas is additive manufacturing, which is an emerging technology used to manufacture customized products Like a facial implant that is surgically inserted into patients who have lost the significant portions of their facial bone structure due to cancer or other diseases. The next major research area is data science, which focuses on the development of innovative machine learning and optimization techniques to produce novel, efficient, and robust data science technologies for use in industrial engineering. Data science techniques can be used on extremely large data sets to computationally reveal patterns, trends, and associations, especially relating to human behavior and interactions. Application domains include forecasting, customer segmentation, production quality control, and supply chain performance prediction. The Industrial Engineering Department aims to keep its finger on the pulse when it comes to innovations such as machine learning and data analytics, providing the necessary future-proofing of our bachelor's degree. Operations and supply chain management is another major research theme which focuses on process excellence from both intra-organizational and inter-organizational points of view. The first of the three main sub-areas is physical asset management, which involves the systematic and coordinated activities through which organizations optimally and sustainably manage their assets over their respective life cycles. The next key sub-area is supply chain management. The key research focus is on the digitalization of operations, supply chains, and value chains in both the manufacturing, retail, and service environments. The last main sub-area is called learning factories. The Stellenbosch Learning Factory provides a research facility for topics related to the smart factory of the future, which is in line with the fourth industrial revolution movement. In order to bridge the skills shortage gap at a tertiary level, the Stellenbosch Learning Factory was established. Learning factories involve experiential learning in a production environment through learning by doing. Operations research is another major research theme, which is focused on the development of mathematical models and their incorporation into computerized systems aimed at supporting scientifically justifiable and effective decisions in industry. Some valuable real-world problems addressed by our operations researchers include routing and scheduling decisions for fleets of delivery vehicles, employee duty roster or timetabling decisions for the manufacturing and health sectors, shelf space allocation and inventory decisions for retailers, crop irrigation and agricultural pest control strategy decisions, and lastly, optimal facility or production plant layout. The last major research theme is engineering management, which consists of enterprise engineering, sustainable systems, health systems engineering, and industrial policy and beneficiation of minerals. Problems addressed in this research theme range from conceptualizing novel, engineering-based solutions towards the challenges faced by the healthcare sector to the analysis, development, and evaluation of inclusive innovations. Industrial engineering is truly a forward-thinking discipline focused on solving difficult, diverse, and important real-world problems. According to a recent survey by the South African Institute for Industrial Engineering, almost a third of industrial engineers have a postgraduate qualification. Fortunately, our department offers both a diverse spectrum of research themes and a selection of top academics that are at the forefront of their fields. Our department boasts over 20 lecturing and supervisory staff, of which a vast majority are professors and doctorates. The following postgraduate options are available at our department. They are a postgraduate diploma, a structured master's, a research master's, and of course a PhD. Our department therefore provides a broad selection of future avenues towards deepening students' intellectual offerings. In conclusion, thank you for watching this virtual tour of our field of study and our dynamic department. We hope that you can now make an informed decision regarding your possible pursuit of an industrial engineering degree at Stellenbosch University. For any additional queries, please contact the following staff or visit our website at the following link. We really hope to see you next year at Stellenbosch University, studying industrial engineering at our department. Thank you very much.